Hello there, once again, gentlemen and gentlemen. Ladies are invited too, although I don't see any on the list. Welcome back to Al's varying sequence of videos, where I've gone back to my stamp collection wallpaper. And I thought that, maybe it's time now to have another look at the collection and maybe look at another interesting person in this collection. And since we talked about Tycho Brahe, I thought that Galileo would be a good follow-up from Tycho, since Tycho's work eventually led up to the things that Galileo discovered, but more in keeping with characteristics. These two fellows had similar characteristics in being strong-willed and hard-nosed. This nose a lot harder than this one. Skeptical. Both seeing the sun-centered system as being probably the correct model of the universe, unlike what the church had on offer. Which I should, before going on to, what I've done is, one of my directories here, I've made some videos, and what they are actually clips from videos from my other channel of someone else talking about these various figures. First, a little bit about Copernicus, a little bit on Tycho Brahe that you already know, and a couple on Galileo, split up because I want to put a comment in between there, this and this. Now, as you probably know, Copernicus, out of this group, would have come first, and these people are in chronological order. I even wrote down the dates. This one is not mentioned anywhere, but I'll mention him later. Copernicus, Brahe, Galileo. You'll notice that Galileo and Brahe were nearly, what do you call it? Lived at in the same time. They lived in the same time period. Copernicus died before either the two had been born. And one of the things I want to mention before showing you those little clips is the narrator, James Burke, is constantly referring to the church and its obsession with Aristotle, and how, and that's not explained. What does the Catholic Church have to do with Aristotle, and how did that ever come about anyway? Because the Catholic Church initially had nothing to do with Aristotle. According to themselves, I kind of doubt it. I looked this up. The Catholic Church was founded by Jesus Christ, and that's supposed to be in their view, their God, and also the descendant of their God, and also something else. It's a very complicated religion, and it's also a very accommodating one. and it has changed over and over in time. The philosophy has. It was the main, according to this anyway, in terms of the Roman Empire, it was the state religion of the Roman Empire by decree of the emperor. You got to remember, of course, that in those days, 313 or whatever, there were no such things as countries or nation states as we know them now. There were empires and kingdoms, sometimes little kingdoms and things like that. But the concept of the nation state is a much more modern one. Eventually, the western part of Rome collapsed, and that period after that collapse is what we call the Dark Ages. And what was left of the church in the western part of Europe broke up into these little kingdoms and things, and they built monasteries. So they had monasteries and monks and missionaries, but they still had, I think, bishops, and the authority was still Pope. The Pope was still the authority in Western Europe. But of course, nobody really cared because everything had been destroyed, and they were just trying to survive, basically, whoever was left alive after the fall of Rome in that part of the world. But eventually, and it's not explained in a very linear way here. Eventually, it became a kind of in the West, it was an us and them, with the us being the Catholics, the people being governed by the church, with the Pope as their prime leader, and the East being the Arabs, essentially, right? So it was an us and them, with us being the Westerners and them being Arabs. Still nothing to do with Aristotle. But eventually, what happened was this. In 1085, a tiny little Spanish town called Toledo was taken over by the West, or by the northern Christian mob, and what they discovered there were libraries and books which contained it was written in Arabic, but it was most of the books and the information had been translations from Greek, and that included sciences and mathematics and astronomy and medicine, engineering, everything, eventually leading to the enlightenment, as they call it, the so-called enlightenment, and of course, in those writings were the writings of Aristotle, and it was the Aristotle bit that really allowed the kind of ignorant Westerners to make some sense out of the translations. And one of the things that Aristotle had developed was his system of logic. But the church, of course, now logic was something that was, how can one say, once people started hearing about this logic thing and using it, they started to apply the system of logic to the Bible and the Bible writings, and showed that the Bible had contained contradiction and wrong things. So the church, the Christian church, was very much against the distribution of such ideas as it threatened their authority. But eventually, the Christian church, as I said, is a very accommodating one. And so they just decided that, okay, well, there's, the Bible has one kind of truth, the revealed truth, and then there's like the everyday truth that Aristotle's talking about, and it's fine we'll allow that people to use logic and so on, but just not with respect to the Bible. And part of Aristotle's point of view was, of course, that the Earth was the center of the universe, and the church liked that. And eventually, over time, Aristotle's writing became part and parcel, as they say, with the Christian doctrine. So once, at one time, rejected by the church, and then eventually becoming the doctrine of the church, and then contradicting Aristotle became a bad thing to do. And so that's how this whole business of the dangers of suggesting that the Earth might not be the center of the universe came about. It wouldn't have been a problem if Aristotle, you see, he's even mentioned, I'm not even reading this, but I just noticed, if Aristotle didn't become an integral part of the Catholic Church, which it hadn't been up until the fall of Toledo, and in fact it took several years before they even sorted out what they found. Anyway, I'll play the first bit here, following, and I'm going to pause this and play it for myself so I can figure out what I'm going to say after.
Meanwhile, as they say when the plot's about to thicken, meanwhile, up here in the Polish port of Frombork, the plot was about to thicken. The plan, you remember, with all that song and dance stuff, was to get them flocking into church, right? Okay, then what? I mean, when was then? Were you in Easter, Lent, or February the 29th? Because salvation-wise, what you did in church depended on what the date was. And that was just it. They didn't know exactly. For instance, if Easter was supposed to fall on the first Sunday after the first full moon, after the beginning of the spring equinox, which depended on a moon-sun cycle that couldn't be checked correctly except every 312.5 years, and anyway that night the moon didn't come up, and the calendar you were using was 9 days out, which it was, I mean, what? But church authority was what held the whole of society together, everybody from the prince in his castle down, and it depended on the faithful doing what they were supposed to do at the right time. Small wonder the Pope wanted the sun and the moon checked out better than they had been so far. Well, when they were, here at the castle of Frombork, his troubles were over. But not for long. Because the astronomer priest here, who had a go at clearing up the confusion in the sky, succeeded, and in doing so blew everything to kingdom come, if you'll forgive the phrase. Let me explain why his work was so revolutionary. See, back at the beginning of the 16th century, what was up there was what Aristotle said there was, had said 2,000 years before. It was a straight common sense, as I see it, view. Let me show you a model of it. Here, at the center of everything, the Earth. Static. Well, you can't feel any motion, can you? All around here, on concentric crystal spheres, pushed through the sky by angels, the moon, the sun, the planets and the stars. All wheeling around once a day in heavenly, unchanging circles. Well, they do, don't they? Heavenly motion was evidently circular. Here on Earth, on the other hand, things only moved one way, in straight lines, up or down. So, if celestial circles were eternal, obviously straight line earthly movement had to be the reason we weren't eternal. Movement special to Earth. Okay, this priest here in 1512 or so took a closer look at the heavenly arrangement and didn't much like what he saw, which was Mars, for instance, among others, being very un-Aristotle. I mean, it appeared sometimes to go backwards. Now, that was supposed to be impossible. So people had got round the difficulty with this little gizmo here. See, there's Mars. It goes forward on its main circle, while on an extra mini-circle it goes backwards. Backwards. Good, eh? Solved the problem. Trouble was, to make the entire solar system work in pure Aristotle terms like that, took over 90 of those little fiddly bits. It occurred to Copernicus, our priest, that there might be a simpler way that would still be circular and that would allow for things seeming to go backwards. So he came up with this. If you put the sun at the center and the Earth in orbit, then you know what we now know, that that view of Mars going backwards isn't real. It's because it's in a slower orbit further out than Earth. Most of the time everybody appears to be going forwards, and then when we pass Mars, it appears to go backwards. And then at other times, forwards again. And similar problems for the whole sky were solved by this sun-centered system. Copernicus published his manuscript in 1543, just in time for the Council of Trent. So, you're a church father. What this new system of Copernicus is saying is this. The Earth moves, although the Bible says it doesn't. It's no longer at the center of God's universe, although the Bible says it is. It's a planet, so heaven and earth are no longer separate. And Aristotle is wrong, though church authority depends on Aristotle being right. So, you're a church father. You pick up this subversive, heretical, revolutionary lunacy, and what do? Foam at the mouth, right? Wrong.
Okay. Wrong, because the church didn't consider what Copernicus had written, as saying anything about the real world. To them, it was just interesting mathematics. Astronomers draw circles and lines in the sky, but that's not a real thing. It's just a mathematical convenience. It helps with the calculations, and in particular, in getting the date right for the things that he just mentioned. Now, Brahe didn't see it that way. It wasn't just fancy mathematics. The universe doesn't necessarily have to be Earth-centered, whatever Aristotle might have to say about it. Is his business, but it's just an opinion. It's not. It wasn't based on anything factual. Aristotle's view is the common sense view. If the Earth is really moving, how come there's no wind and things like that? Why don't you feel it? And okay, sure, fair enough. That's a good question. But on the other hand, with the Earth not moving, the motions of things doesn't really make much sense. With the Earth being in orbit, the motion of things does make some sense. And so he went on to do his thing, which I will now play that little bit. And again, pausing this.
Some more things that weren't supposed to happen were about to. Here, on what has to be one of the more underwhelming places on Earth, the island of Vane, between Sweden and Denmark, both of whom often claim it belongs to the other. Still, if it hadn't been quite so featureless, he might have been less observant. He? Him, the one with the crick in his neck. Danish nobleman, and the only astronomer in history with a metal replacement nose, Tycho Brahe. One evening in 1572, in his customary position, staring up, Brahe noticed a new light in the sky, made a few notes on the subject, and became the rage of Europe, because Aristotle had said the sky was perfect and unchanging, and new stars couldn't happen. So what was this? And it had no parallax. Parallax is the way a thing seems to shift as you do. Look, watch this nearby cart compared with that distant lighthouse as I move my view. See the cart move? That's a shift in parallax. The lighthouse doesn't shift because it's too far away to show on that small move. Now you take a giant move, like the Earth going around the sun. Anything you watch during that will have to be a long way away not to shift at all. And Brahe's new star didn't. So it was a star. Well, the King of Denmark was so impressed, he offloaded the island on Brahe as a base of operations, plus a financial sweetener. And Brahe turned up here, dug this hole to put a castle in, and generally started behaving like a little Hitler. Nasty piece of work by all accounts. Anyway, you'll have noticed the wind. So did he, and built his observatory down another hole to get away from it. Went down this second hole every night for 20 years. Not much else to do around here. And whereas all other astronomers were content with the odd observation or two, Brahe watched everything, all night, every night, with instruments like this, for measuring the angle of the heavenly bodies, and came up with a mountain of data, which was why he was able to be clever.
The next sentence there was about the next shock horror in the sky, and that had to do with a comet coming in through Aristotle's crystal spheres. Anyway, that much we already talked about Tycho, and you will have noticed a correction that I put in there when speaking about parallax. The reason that although it's true that what Tycho saw was a new star, it could not have been proven to be a new star by means of it not having parallax in those days, because it was still the Aristotle view in place. So it had to have been explained as a new star for the simple reason that according to the model, right? That model, you saw a picture of it with the 5 spheres or whatever. It wasn't on any of the 5 spheres, and it moved in a precisely rigid way, with what would have been the outer shell where the stars would be. So therefore, it would have been interpreted as a star from Galileo's point of view as well. And now, not Galileo, from Copernicus, from Aristotle's point of view as well. So, as an Aristotelian, in an Aristotelian universe, it was a star. In a Copernican universe, it was also a star. So, okay, there's that. Now, there are 2 bits about Galileo that I want to play, and so I'm doing all this continuously. I'll chop this up. I'm going to do the next bit now, and have a look for myself where it ends.
Well, guess what happened next? Yes, only this time the mathematics professor involved slowed the falling ball process down by rolling his balls down a slope, marked with numbers at equal intervals to see how long it all took. He used a pendulum swing to get split-second timing on when he released each ball. He spent months rolling different weight balls down different angle slopes, hundreds of times, so as to get accurate average figures. And each time, watching how long it took the ball to go different lengths of the slope. A third, quarter, fifth, eighth, half, and so on. He measured the time with water. As the ball rolled whatever distance it was supposed to, he'd run water at a steady rate into a measuring jar because he could see immediately from each amount whether the ball was taking different times to do different bits of the journey. In other words, if it was accelerating as it went down the slope. What Galileo was looking for was some kind of law that all falling objects obeyed. In 1604, he found it. Everything accelerated as it fell at exactly the same rate, by Galileo's law we all learnt at school, 32 feet per second per second.
Okay, now I know why I stopped that there. And there is no correction really, obviously in those subtitles. I don't know for sure, I haven't checked, but if Galileo's measurements were based on those experiments described in that video, he would not have arrived at the figure 32 feet per second like that, 32 feet per second squared, for the simple fact that he's rolling balls down planes. Now balls, even if somehow or other he were able to translate those experiments to predicting what the acceleration of a free fall would be, he would have come up with a wrong answer. I mean, an answer different from this. He must have, if he did come up with this number, it must have been through experiments to do with free fall. First establish that there's an acceleration. Next establish or find out what that acceleration is for free fall. And the third step, try it with different masses and weights and see that it's the same for all. If you do try this experiment yourself and you try to figure out what g, the acceleration due to gravity, is, you're going to find a result which is off by, if those were solid spheres, it should be off by, I calculated that myself here somewhere. Is this the one? 2, 7. First I had it wrong, and then I moved, and I had it correct. Well, the answer is that 7 tenths, no, 10/7. Oh, sorry, 5. Okay, 5/7. 5/7 of G. Okay, so whatever that is. So it's 32 feet per second times 5 divided by 7. So yeah, 22.8. You would have got 22 feet per second squared rather than the correct answer, 32. And the reason for that, again, is because a ball has some shape, and as it's rolling down one of those planes, it costs some energy to make that rotation occur, and so the final speed at the bottom of the ramp is not what you would get if you just had a block of ice slide down frictionless surface the same distance, because the ice doesn't gain any rotations, but this thing does. Okay, now let's play the last little bit.
What Galileo was looking for was some kind of law that all falling objects obeyed. In 1604, he found it. Everything accelerated as it fell at exactly the same rate, by Galileo's law we all learnt at school, 32 feet per second per second. It was the first time nature had been described by mathematics that could be used in any circumstance to describe what nature was doing, the beginning of what we know today as the scientific revolution. Now, all that may look very mathematical and esoteric to you, but in 1605, doing that kind of thing with balls was dangerous, because what Galileo had discovered was the thing that Aristotle said couldn't exist, a universal law of acceleration that every single falling object on Earth would obey, and never mind all that nonsense about each object its own unique characteristic. Now, contradicting Aristotle like that could have made life very hairy for Galileo, had events not taken a turn for the safer, with a new business proposition. In July 1609, a friend of his showed him the new wonder machine from Holland, a telescope. And 1 month later, Galileo was here in St. Mark's Square in Venice with a financially very attractive idea in long-range optics. Up here, he said, look through this, he suggested to a group of shipping merchants. Galileo's new improved version of the optical gizmo would magnify distant objects 9 times, and that meant that you could spot the ships coming into anchor out there, a full 2 hours ahead of the average naked eye. And that meant that you could get out your little commodity list, ship symbol, cargo, value, and fix the market prices accordingly, because you knew the ship was coming in and your customers didn't. Nice idea, they said. We'll take 30, and here's a fat salary to keep it in the family. But a bull-headed, arrogant exhibitionist like Galileo couldn't keep his mouth or his options closed. And in 1610 he did something only a lunatic would do. He pointed an even better version of his telescope at the one place Aristotle and the church said not to. Up there. And when he saw what he saw, he compounded the felony by going public in a little 24-page booklet called The Starry Messenger that blew 2,500 years of authority and status quo right out of the window. Because in a few scribbled illustrations, Galileo took the universe apart. Look, here's the moon. Not perfect and incorruptible like Aristotle said it was, but with mountains, just like the Earth. And millions more stars than there were supposed to be. And look at this, the unthinkable. 3 or 4 little satellites going round Jupiter when everything was supposed to go round the Earth. And a bit later, here he is saying that even the sun isn't perfect. It's got spots. And then the clincher, Venus looked like the moon sometimes, waxing and waning. And that meant that we were seeing it illuminated differently as it went round the sun. So all of this was visible proof that Copernicus was right after all. Everything went round the sun. Even then, Galileo might have managed to keep things sweet. Had it not been for one breakfast time when his boss's wife, the Duchess of Tuscany, asked a friend of his if all this didn't mean that when the Bible said the earth stood still, it was wrong. Well, in a polite letter explaining things to her, Galileo said yes, and not to put too fine a point on it, scientifically speaking, the Bible was wrong. And then everything hit the fan. Now, the conventional view of what happened next is that the church decided to arrest Galileo and shut his mouth for good. Well, he was arrested and shut up, but only after an infuriated church had bent over backwards not to. They said, look, we know you're right, but you can't just spring it on the masses. You've got to let us tell them slowly. Galileo told them to get lost. Then he was arrested. Copernicus was prohibited, and that, for the Catholic Church, was that.
Okay, now that last little bit, again, showing how the Catholic Church, how accommodating the Catholic Church is and always has been with, adopting new ideas to their doctrine. The only caveat is, whatever happens to be true happens to be true. But we're the authority, and we're the ones that tell people what's true. And you don't go ahead and start contradicting our doctrine on your own, because that makes us look bad. And we're the ones in charge, and so we're the ones that are going to decree suddenly at some point that the Earth is no longer at the center of the universe. And then we'll dump Aristotle in our own way. Well, that's the way the Church, the Catholic Church, seems to operate, and in operating in that manner, is able to maintain authority. Anything that there's nothing that can contradict the Catholic Church doctrine, because it does not have a doctrine, a fixed doctrine. It has its current doctrine, which is constantly subject to change depending on what's found out in the world. They're perfectly aware of the fact that there are wrong things in the Bible, but they are not going to nobody else is going to be the one to point that out. Otherwise, they would look bad, and people would start losing faith, not in the religion, but in the church and its authority, since the Catholic Church is a power system, seeks to maintain, as all power systems do. Now, I don't know how much time that in total that is. There's probably not much left for me to say something about the code, but I'll see. I'm going to stitch all that together and we'll see what happens. Okay, well, that appears to make for an entire video. I just wanted to add a few things that I forgot and left out. One is those instruments Brahe used for his measurements were self-designed and built, not any particular brand, although they look like geological instruments, surveying instruments. The optical gizmo, otherwise known as the telescope, now known as a telescope, was not invented by Galileo. It was an improved version, I think it was mentioned, of the device whose invention is afforded to, or the inventor of the telescope is generally accepted to be Hans Lippershey, who I have in my favorites. I have a list of many people. Inventor of telescope, although it was not called a telescope at the time. Even in Galileo's time. And there it is, he was a spectacle maker, invented something called a telescope, which was vastly improved on by Galileo. Galileo had his own version. The reason I know that it was not called a telescope at that time is because I happen to have a copy here that I prepared for this video, getting the copy of Galileo's The Starry Messenger. It's been reprinted, but this is the original text, translated, I suppose, where he refers to it as a spyglass, and that has a little 3 on it. The word telescope was not coined until 1611, and you can find out more about that here. Now, this is the Starry Messenger, same one mentioned in the video. Here he's explaining how the optical gizmo works, I suppose, the magnifying thing. Here are some of the sketches. More. Some theory about circles, and here is a blow up, I guess, of the Sword of Orion. And I guess these stars may not have been seen before. Somewhere there should be something about sunspots, according to the video. Let's see. It's supposed to be 23 pages, and I've only got 15. So I think I didn't get the whole thing. Yeah, I have part of it. Unless there's a next. I don't know what this does. What does this do? Nothing. But I know the whole thing is available online somewhere. What else did I forget to mention? Oh yes, although as great as Galileo was in what he achieved, by being the way he was, wiki, Galileo, and his refusal to go along with the church actually might have had the opposite effect, because that was when the ban on Copernicus was instated by the church. So when Galileo was put under house arrest for the duration of his life, at the same time, all copies of Copernicus's work were rounded up and removed from the bookshelves of libraries all over Europe, except for parts of Northern Europe. But for the most part, Copernicus was banned. And one last thing that I think I should include with this, since I'm on the topic anyway, speaking of Copernicus, is an unknown figure in history that is also mentioned in that same video right at the end. And I'll play that little end bit following this. You can decide for yourself whether or not you think this person is worth remembering, worth having been put into the memories of people, of human beings on this planet. Okay, well, that's it for me. Enjoy the rest.
We end the story where we began, here in the Empress Maria Theresa's palace in Vienna. Because the year Halley's Comet was due back, 1757, there was a fellow here who was, so to speak, to dot the I's and cross the T's on the whole affair. He was a Jesuit astronomer and mathematician, engineer, geographer, geodeticist, and general genius called Roger Boscovich. Now, Boscovich had done a lot of work on comets, like how to get a very accurate handle on their trajectory from any 3 observations. And he'd put in a prize-winning paper to the French Academy of Sciences, he was one of their foreign correspondents, on the interaction between Jupiter and Saturn. And it was through that enormous gravitational tug-of-war that the returning Halley Comet had to come on its way back into the solar system. The question was, when? That's why the Boscovich work was kind of vital to the French astronomers watching for Halley, because it told them that the comet would be returning late, even before they picked it up on their telescopes. Thanks to Boscovich, they knew it would be 19 months late. I said Boscovich ended the story for another reason too. He was, among his many talents, like fixing the cracks in Maria Theresa's library, also science advisor to the Pope. And it was mainly due to him that the prohibition on Copernicus would be lifted.